Okay, class, so we have arrived to chapter 8, and here we're going to be looking at analytical geometry. And before we jump into that, I want to take a moment to review distance and midpoint formulas. So we want to find the distance d between the points 2, 4 and 5, 8. Here's our point 2, 4. Here's our point 5, 8. And our goal is really to figure out, well, what is this distance here? Now, if I took a ruler, I could definitely measure it, but we don't, by looking at this, I can't just count how much it is. So what we need to do is we're going to go ahead and let's change the color here just so that we can see it. We're going to have to take this value and this value. We're going to have to find both of these and then use the distance formula. So here, let's figure out what point this is. Well, this point, if this is 2, 4, this is going to be the point 5. We know it's 5 because that's 5. But this is going to be 5, 4. Okay. So let's figure out what this distance is here. What is this distance? Well, this is a straight line. So I can tell that this distance is just going to be equal to 5 minus 2. I'm at 5 over here and I started at 2. So it's going to be 3. So this is a distance of 3 units. Okay. Now here, the distance between, I started at 4, I'm going all the way to 8. The distance here is going to be 8 minus 4, which gives us 4 units. Now by creating this, notice that I did create a right triangle. Okay, and we have talked about Pythagoras' theorem, right? And Pythagorean theorem tells us that if I have a squared plus b squared, this equals c squared. And our c is going to be our hypotenuse. This guy here. So let's go ahead and figure this out. So I have 3 units squared plus 4 units squared equals c units squared. So 3 squared is going to give me 9 plus 16 equals c squared. Well, 9 plus 16, that gives me 25. So now I'm going to take the square root of both sides, and I'm going to see that c is equal to 5. And in this case, it only equals 5 and not negative 5 because we're talking about a distance. So that means that our distance is equal to 5 units. Okay. Now, as much as, we'd want to do this and draw out the picture every time we have a distance between 2 points, we really can visualize it here and come up with the distance formula or generalization of the distance formula here. So what this is telling us is that the distance between 2 points, point 1 here and point 2 all the way out here, notice that we take the absolute value of the distance between our x2 minus our x1, which is what we did when we got our 3 units here. And now we're going to take y2 and subtract y1, and we take the absolute value of that. And that's how we got our 4 units. And we're taking the absolute value of these numbers because we talk about distance, and when we're talking about distance, it's always going to be positive. So the distance between 2 points, P1, x1, y1 is the point value, and P2, x2, y2 is their coordinate value, is denoted by distance of P1 and P2 is, and so we now need to fill it in. So actually, I don't think it's going to fit there, so I'm going to come up here. So our distance formula tells us that we're going to take the square root, and now we're basically going to generalize that Pythagorean theorem. Because if we come back up here, looking at the Pythagorean theorem that we used here, right, we can essentially make this look like c equals the square root of a squared plus b squared. Because notice that that's what happened. A squared plus b squared equals c squared. We found out what those sums were and took the square root of it. So c equals the square root of a squared plus b squared. So this is really our distance formula, but let's generalize this a little bit more. What was a squared? Well, a squared was my x values being subtracted. So that's going to be my x2 minus my x1, but I'm going to square that, and I'm going to add that to my b squared. So my b squared was the difference of my y values. And so here we have the distance formula. So the distance between any 2 points, we're going to subtract the x values, square it. Then we're going to add the difference between the y values squared, and we're going to take the square root of that. And that gives us the distance between any 2 points on a graph. All right, let's continue. Oh, here was the spot. Let's go ahead and fill it in here too. Squared plus y2 minus y1 quantity squared. So let's take a moment and go ahead and calculate the distance for both point A and point B. Okay, so in doing the distance formula for the first one, did you get D equals 15? All right, we should be able to do the subtraction. 5 minus -4, that's going to give us a 9. We square that, we get the 81. -11 minus 1, that gives us a -12, but when we square that, we get a positive 144. So we're taking the square root of that and getting 15. Now for B, notice that we were asked to round to the nearest tenth. So in doing the calculations, we do end up with 8.2462. Rounding that to the nearest tenth, that's going to be the 2. And because the helper is less than 5, it's going to keep it as a 2. So our answer is just 8.2 for that one. All right, let's take a look at midpoint formula. The midpoint formula of a line segment connecting 2 points x1, y1, and x2, y2 is the point whose coordinates are given by this value here. x1 plus x2 over 2 and y1 plus y2 over 2. The midpoint of the line segments that connect the points 4, -7 and 1, -1, -3. So we want to find this. Oh, you know what? I didn't leave enough space here. Sorry about that. But let's go ahead and calculate this one. So for number 2, find the midpoint of a line segment that connects these 2 points. So we're going to use x1 plus x2. So our midpoint M, I should have noted that M equals this, is going to be given to us by x1 and x2. So we're going to add those two together. So 4 plus -1 all over 2. And then the next number is going to be our y value. So we're going to have, oops, sorry about that, class. We're going to have -3. Sorry, hold on, I want to keep it consistent. -7 plus -3 all over 2. All right, so when we calculate this, we're going to get 4 plus -1. That's going to give us a 3 over 2. And -7 plus -3. It's going to give us a -10 over 2, which gives us a -5. So our midpoint is going to be 3/2 and -5. All right, look at this. Consider the 3 points A, -2, 3, B, 2, 0, and C, 5, 4. We're going to plot each of these in the Cartesian plane, and we're going to create a triangle ABC. So let's go ahead and draw our axes. We are going to have some negative numbers. So let's go about here. We're going to pretend that's a straight line. And here. All right, so once we have our axes, we're going to go ahead and plot these points. So we're going to be at -2, 3. So here's 1, 2, 3, 1, 2, 3. And this is going to be A. And then we're going to go B is 2, 0. So here's 1, 2. Here's 0. This is our B at 2, 0. And lastly, 5, 4. So if this is 2, 3, 4, 5, 4, 1, 2, 3, 4. And this is C, 5, 4. So we have created this triangle here. Okay. All right, so there's our triangle ABC. Find the length of each side of the triangle. So we want to be able to calculate all of these distances. So take a moment and find this distance here. Let's start with B to C. What would this distance be? So that's going to be the distance between, so line segment BC, the distance between points 2 comma 0, and 5 comma 4. All right, so take a moment to calculate that. All right, for B to C, that line segment 2 comma 0 to 5 comma 4, did you get 5 units? All right, so that's going to be 5 unit difference. Now I want you to go ahead and let's calculate A to C. Let's figure out this distance here. Take a moment to do that. All right, so for this one, we're looking at the point -2, 3, and 5, 4. Did you get 5 root 2 or 7.07 units? So that's telling us that this distance is 7.07 units. All right, our last side here, let's go ahead and calculate A to B. So it's going to be this side right here. And so AB is going to be the points -2 comma 3 and 2 comma 0. Go ahead and calculate that distance. All right, for our last one here, did you get 5 units? So we have 2 lengths of 5 units and then 7.07 going from A to C. Now the next question is asking us, verify that the triangle is a right triangle. So we want to verify that it's a right triangle. So the way that we would verify this is we'd use Pythagoras' theorem, because a squared plus b squared equals c squared, and this is true for right triangles. So here I would have 5 squared plus 5 squared equals c squared. Well, 5 squared is 25 plus 25. The question is, does that equal c squared? So this would be 50 equals c squared. So c equals the square root of 50, or 2 root 5. And that is true. So this is in fact a right triangle. So we would have had a right triangle here. All right, and lastly, let's find the area of a triangle. So the area of a triangle would be 1/2 base times height. Well, we're going to take a half, and we already calculated the base and the height. So if you kind of imagine rotating this triangle, it would look like this. So that you can see that here's my base, here's my height, and then here's 2 root 5. This would have been that diagonal. Okay, so I basically rotated this triangle this way a little bit. So my base would have been 5, and my height would have been 5. So it ended up with 1/2 times 25. So we'd end up with 25.5 units squared as the area. Okay. All right, hopefully that made sense. Good practice there for the distance formula. All right, that's where we're going to end up here. In the next video, I'm going to talk about reviewing circles, and we're going to talk a little bit more about circles.